Welcome, Michael, to Big Data Cloud, and thanks for joining us here.
Oh, thank you.
Sure, thank you so much. And we have today a few general questions that we would love to understand your perspective, and especially in big data area. It's a buzzword right now. So my very first question is, at this time when we see that enterprises or smaller startup in Silicon Valley or globally, in terms of solving big data processing problems, we seem to be going towards using file-based systems. Those are not even databases. So question for you is, instead of fine-tuning the architecture of existing DBMSs, their MPP architectures are around for a long time. They have been very successful to solve the 3 V's of big data. Instead of, moving towards fine-tuning existing technologies, we see that we are moving towards using file-based systems. So, so on that, Michael, what do you think, and what's your thought around that? Are we going backward in terms of innovation of the BMS technologies, or we are moving forward?
I think file-based technology is a huge mistake. And so let's talk about it in the context of the 3 V's that you mentioned earlier. So big volume, you've got too much data. Big velocity, it's coming at you too fast. And big variety, it's coming from too many places.
Yeah.
So in the big variety world, that's a schema integration problem, and that's just really hard, period. And in point of fact, the traditional data integration technology that is the standard wisdom is to use an extract, transform, and load system such as Informatica or Essential. Those are database based.
Yeah.
So now let's look at big velocity, which is you're trying to drink from a fire hose. None of that is file-based technology. That is real-time pattern matching, and the systems. Well, big velocity means either you're drinking from a fire hose, and you're either trying to find complex patterns in the incoming data. So that's the problem that the electronic trading guys have on Wall Street. In that case, that's a real-time main memory pattern matching system. Has nothing to do with either files or databases. On the other hand, if you're trying to do big velocity and you have big state and little pattern as opposed to big pattern and little state, an example would be there's a company I know of that does electronic trading that has a trading system in Tokyo, another one in Hong Kong, another one in New York, and they want to construct their real-time position for or against every stock on the planet. So they want to just assemble a computation on their fire hose, and the fire hose is coming from all over the place. That's a main memory database problem, and is solved by main memory technology. It's not a file technology at all. So big velocity is not a file system problem ever. So big volume is really the case that you're talking about. And that comes from 2 places, or your question probably comes from 2 places. Number 1, from Hadoop, and number 2, from scientific data, high-performance computing. So file systems are very popular in both of those worlds. In data warehouses, everybody uses databases. So we'll just deal with those 2 cases. So I'm involved in a couple of very big science projects, and they are all tearing their hair out because there's no schema, it's hard to share data. And so I think future big science projects are going to be database based because they've figured out that the databases actually add value. The best example is the Large Synoptic Survey Telescope, which is the next big science astronomy project. and the telescopes being built and put up in Chile right now, that will be a database-based system. It won't be a file-based system.
Wow.
They've already decided that. So then we get to Hadoop, which is my favorite thing to talk about.
Sure.
Now, if you go to one of the big Facebook proponents, big Hadoop proponents, which is Facebook, 95% of their traffic is in fact in Hive. It's not in Hadoop. So by and large, the entire world is moving to Hive, and Hive is a query language.
Yeah.
And it doesn't much matter what's underneath it.
Yeah.
The user is issuing queries.
Yeah.
He's not interacting with files. Now, the interesting thing that I find is that Hadoop, the stack used to be Hive on top of Hadoop on top of HDFS, which is a file system.
Yeah.
So Cloudera just recently announced a system called Impala, and Impala processes Hive, but it doesn't do it through Hadoop. It goes directly to HDFS. So Hadoop is being tossed aside because it doesn't work very well at all. And so if you have Hive on top of an engine on top of HDFS, that's essentially the same thing as Vertica, which has an engine on top of Linux files. So you're basically using database technology, and the implementations are moving to things that look exactly like parallel databases. And Impala is a parallel database. And so I think the world is actually moving away from file systems, not toward file systems.
Wow. Yeah. Michael, as a system integrator at Third Eye Consulting Services, we are a big data services company. Enterprises often ask us for their big data processing. All enterprises want to, seem to like to process, social data to more beyond their enterprise data. It's a common thing going on. And they often ask us, basing on their application, which big data technology is best suited for them. And definitely application by application, the technology, the choice we can give them, it varies. But at the same time, there are zillions of technologies that we see in the industry now, and zillions of distributions of the same technology.
Yep.
And what would be your advice to the enterprises to what they should watch out before picking the technology if they are planning for next 10 years, 20 years?
Okay, great question.
Sure.
So I think I could just give you a few reactions. The first one is there is so much hype around big data, and historically one of the things that really bothers me about the computer business is that vendors routinely lie. And so some of the biggest vendors are some of the worst offenders in not telling the truth. So that's led to a climate of where anything you're interested in, you have got to test in your environment, and so there's no shortcut to the finalists in any problem that you're thinking about. You've really got to bring them in-house and kick the tires hard.
Yeah.
So that's advice number one.
POC.
Do a pilot.
Yeah.
And the second advice is don't let the vendor do the pilot. Do it yourself, because the vendor can always get his stuff to work. He always codes around his bugs. You have no idea whether his documentation is accurate or not. You have no idea what tech support is like. Whereas if you do the pilot, you get to find all that out. And so there is just no shortcut to you doing the pilot and see how the vendors perform.
Sure.
Both in terms of how hard it is to do the app, how it runs, how good is their documentation, how good is their technical support, all of that. So there's no shortcut to doing that. Now, in terms of how to choose the finalists, I think there are some clear winners and clear losers. So like in the big volume data warehouse sector in general, column stores are going to kill row stores. And so there are going to be, and all vendors, all data warehouse vendors are moving toward column stores, some faster than others. And so, you know, if your vendor of choice isn't going to get you to a column store fairly quickly, he's going to lose.
Yeah.
And so another thing to think about is if you're going to run Hadoop for some reason, and then for gosh sake, program in Hive. So get the users up to a high level, because what's going to happen is if you just run Hive on top of vanilla Hadoop, it's going to run a factor of 50 slower than something else. And so you can do a pilot on crummy implementations, but then, you know, when you hit the wall performance-wise, you can swap out your crummy implementation for something better. And all the high-performance data warehouse systems are going to, you know, either do now or will soon support Hive. The third thing is do not run anything that is not a multi-node parallel system, that isn't MPP, because nothing, you know, if you run shared memory systems or shared disk systems, they simply are not going to scale. And so you've got to run something that will scale. So that's kind of the three things to think about off the top of my head.
Sure, definitely. This is really greatly helpful. Of course, without POC, you know, we always say that, you know, one enterprise cannot choose. And again, even if we do a POC with a product for an enterprise, then they might have, you know, zillions of applications. And that POC could be really successful for a subset of the applications, may not be applicable. So application assessment, and coming from more of a business application perspective, and then to assess what technology would be the best. So usually that's what we, you know, work
well, I think
on.
A fourth general comment that just I thought of.
Yeah.
So if you have a very simple application, you can run a key value store, and there are plenty of them in the NoSQL world. On the other hand, VoltDB, which is a SQL database system, supports the same key value store as a little simulation layer on top of something more general. If you run a key value store and next year you need new capabilities, you're kind of out of luck. If you're running a simple system on top of something with more functionality, then you have much more flexibility off into the future. So because I think the one thing about this business is that applications live a long time, and it's unpredictable what you're going to need to do next. I think another general adage along the same lines is there's 75 or so NoSQL engines, none of which support ACID transactions.
Yeah, correct.
And so they will all sell you on, well, you don't need ACID now.
Yeah.
But the trouble is, can you guarantee you don't need ACID tomorrow?
Yeah.
And so I think abandoning ACID is a very, very bad idea, because even if you think you don't need it now, you can't guarantee that you won't be up against problems that require ACID next year or next month.
Yeah, a lot of database vendors, they used to be row stores, and they claim that they have column store as well now. And what to me looks like that row stores are great, and we know that column stores are also needed. So let's have one database technology with both the features. And also we see the value of file-based system where the loading is hassle-free, because we spend in enterprise data warehouses a lot of time loading the data when we are talking about historical data processing or for reporting. So I do see that at times, if there is a file-based system, and I can load data very easily, very fast, and do some discovery process. And once I discover, and then I choose to load that data set to the row store. So looks like it's valuable to us. But what would be your opinion? Would there be a database technology or a product where it would have feature like row store, column store, and file system as well? So the users can use that technology or the product and use the features when as they wish. Would this work?
No. So okay, so let's you asked sort of two different questions.
Sure.
The first question is, wouldn't it be nice to have a database system which is both a column store and a row store at the same time?
Yeah.
Now, it turns out that the marketing literature from a very large company claims that, but it doesn't. That's marketing hype. That is not technically correct. So there are, in the big data space, there are row stores, and those are SQL Server, Oracle, and DB2. So all the main vendors are row stores. They are not column stores. The new vendors, Vertica, Parexel in particular, are column stores. They're not row stores. And then there are a class of vendors that I call wannabes, and those include Greenplum and Aster Data. So they used to be row stores. But they're smart people and realize that in the data warehouse market, column stores are a factor of 50 faster. So they are in transition, converting themselves from row stores to column stores. Teradata is in fact in the same situation. So I think there are column store vendors, there are row store vendors, and then there are people in transition going from row stores to column stores. And so everybody will be a column store, and you really cannot have a query execution system that is a row store and a column store at the same time. No one has figured out how to do that. That you're either a column store executor, which is your fundamental operation is pick up a column and do something. This is inside the engine. This isn't on disk. Or your engine is pick up a row and do something with it. So Greenplum has a row executor on top of a column store storage. So they are in transition, but they haven't finished it. Oracle is a row store executor on top of row store data. And so I think no one's figured out how to build a query execution system that can do either one. That's really complicated and something no one has. Now back to loading data. I have two reactions to what you said. The first one is it's a huge issue doing data loading.
Yeah.
And the biggest problem is dirty data.
Yeah.
It's not that people can't load the data, it's that relational database systems reject records that are wrong. And so it's really a cleaning problem.
Yeah.
And it would be very nice to support what I'll call in situ data, which is don't try and load the data, just have the query executor go through your data and give you answers at lower performance than if you actually loaded the data. No one's doing that, and I think that's a great feature, because if you just have a data set and you don't want to clean it, and you just want some answers and you're willing to take sort of dirty answers, or if you only want to run 3 queries and then you're done, then it doesn't pay to go through the hassle of loading your data. And current systems don't do that, and I think that's a great feature to have, and sort of basically external data, in situ data. And some engines have some capabilities, but no one treats that as an important problem, and I think we really should.
Yeah. It is a big task in any DW world, loading data. We spend nights after nights, just supporting nightly loads or 24/7 loads. Yeah. So.
Well, I think having WYSIWYG tools to help you clean your data. I mean, it's all that your data is wrong, and figuring and having great tools that would allow give you a lot of help in cleaning your data.
My very last question, Michael. You have written so many database technologies. So now, why VoltDB? What started it?
Okay, so I wrote a paper in 2005 that basically said one size doesn't fit all.
Yeah.
So historically, everybody, including me, said relational databases are the answer. Yeah, I have a hammer, everything is a nail. And I think that was the popular prevailing wisdom in the 80s and most of the 90s was, well, you have a single engine and it's really powerful and it ought to be able to do everything. Yeah. And I think, at least to me, the wake-up call was when I started to look at data warehouses and I figured out that column stores are wildly faster than the traditional row stores. So I said, a system can't be both a column store and a row store at the same time. So one size clearly cannot fit all.
Sure.
So then you say, well, if in data warehouses there's some vertical market specific technology that allows you to go a factor of 100 faster, that's probably true in other markets. So then I said, well, starting to look at OLTP, the first thing you say is, boy, OLTP databases, a terabyte is a really big OLTP database.
Yeah.
And a terabyte of main memory is no big deal these days. So I said, gee, this is a main memory database problem. So let's start thinking about how to do main memory fast. And you quickly figure out that that's yet a very different implementation from what the traditional vendors have, and also very different than the warehouse-based column stores. So one size doesn't fit all, and the simple answer is that on OLTP data, Volt goes a factor of 100 faster than the traditional guys. Yeah. And if you don't need to do, if you're happy with 10 transactions a second, you can do them on your smartphone. But if you need to go fast, and then Volt will give you a factor of 100 over the other solutions. Wow. And so I think my general thinking right now is that there will be at least a half a dozen different database technologies that are appropriate in various different vertical markets. And that if you don't care about performance, you can do one size fits all. Otherwise, you've got to invest in specialized engines. Yeah,
absolutely. Do you have any plan to write another one after 5 years or even sooner?
Well, I am involved in a company called Paradigm 4 that supports an engine called SciDB, and that does complex analytics very, very fast. Yeah. So that's appropriate if you want to do machine learning and data clustering on very large data sets. If I have another good idea, I will start another company.
Sure. Great. Thank you so much for all your answers. And do you have any message for our Big Data Cloud 500 members that we have now in terms of big data technologies?
Oh, I mean, just pay no attention to the marketing hype. I mean, I think I think number one. Number two, pay up to hire a big data expert who understands what everybody is saying and can figure out what to do, or hire you guys. Sure. And so I think my feeling is that it's the ignorant who get fleeced and get themselves painted into bad corners. Yeah. And so you just got, there's no substitute for getting smart.
Sure. Yeah. Thank you so much. Thank you, Michael, from Big Data Cloud.